Hi, we're going to go to topics 2.5, anti-static precautions and protection. But before we go into that, let's have a little introduction of what is electrostatic charge. Now, this is the terminology of an electrostatic charge, right? So it is accumulation of electrons or protons on the surface of non-conductive. Now, notice here it is non-conductive material. So it's not necessarily metals, okay, such as human bodies, hair, or floors, when an electrical discharge could take place, such as this, right? So we have these two surfaces here, and one surface is with electrons and the other one with protons. And there are basically two types of electrostatic charge, what we call the triboelectric charge and the inductive charge. Oh, let's go to the next slide to know a little bit more about these different charges. So for the triboelectric charge, what is it all about? Okay, so this is the generation of electrostatic charge by friction or successive separation of two surfaces. Now, I'm sure you have encountered something like this, right? When your balloon goes near to the hair of your hand or anywhere, so you can feel there's some charges. So this is in terms as a triboelectric charge. The other one is the inductive charge. Okay, this is the generation of an electrostatic charge when a charged object induces the redistribution of charges in other objects. So over here we have two objects here. So what we have here is the comb, which is negatively charged, right, with electrons, and the paper. So when the comb goes nearest to the paper, right, the side of the paper that's closest to the comb will end up being positively charged due to the attraction of the opposite charges. Okay, so it will attract to the comb. Now, now after knowing what is this electrostatic charge, right, we want to know what is electrostatic discharge, or we commonly know as the ESD. So what is it all about? Okay, so this is discharge. This discharge, right, is transfer of electrostatic charge, which we have just known the two types, between bodies at different electrostatic potentials caused by direct contact, or it is induced by electrostatic field, right? So it occurs in three different manners. The first manner is direct electrostatic discharge to the device. I'm sure you have encountered this before, where you actually you carry some charges. Do you know that? Right. So when you touches another object, you actually the charges is flew to uh, the object there. Okay. So the second one is the electrostatic discharge from the device. Okay. Now this is about this. No, the device may become charged, right? But when you slide down to a feeder and if it contacts to another object or conductive object, right? The rapid charge, this electrostatic discharge occurs from the device to the conductive object. The third one is the field-induced discharge. So now in this case, if an electrostatic sensitive device, right, such as this, is placed in an electrostatic field, like this, and then a charge may be induced on the device. Okay, so this device is being charged, induced by the electrons. Then if the device is suddenly or momentarily grounded by placing on the ground, right, so the discharge will occur. Now, these are the following things that we're going to talk about, this anti-static precaution and protection, right? First of all, we're going to talk about what is electrostatic sensitive device and so on and so forth. Now, what is electrostatic sensitive devices? So these are the electronic devices, okay, or system. So it's the devices or system that are prone or vulnerable to be damaged by electrostatic discharge. Now, you know that these microelectronic devices are becoming very, very popular. Everywhere you see, you go, even the phones are, okay, they are also microelectronic devices. They are very popular now. But because they are very small and they can be used in many avionics equipment, right? So the voltage and current requires of these are very low, millivolts or microvolts. So if this electrostatic sensitive device encounters some charges, okay, it will actually cause damage to them. So it is necessary to observe some precautions when you're doing testing or troubleshooting. So now take a look at here. So these are the devices. Okay, this table here shows the devices that you have on the green, and these are the electrostatic discharge range where damage can occur. So you can see that it ranges from 100 to 7,000 volts, right? It will damage the devices here. So when this the ESD, right, okay, electrostatic sensitive devices, so you need to actually place be identified by this sign here. So if you see this sign, it means that these devices are electrostatic sensitive devices. Now, if the electrostatic devices is there's some discharge over it, right, it can cause damage. Okay, so this you see over here, this is a very obvious damage, okay, caused by ESD, electrostatic discharge. Now, this is obvious. Some of the damage are not so obvious, so it's very difficult to detect. So so it may occur in these two failure here. The first one is what we call the heart failure or the catastrophic failure. Now this one here will cause permanent defects. Straight away it will break down. But the second one is a more tricky one, okay? It's what we call a soft failure or latent defect failure, right? So this is a partial degraded. So it causes partial damage. So you can't really tell that it won't spoil it directly, but over time, right, it may fail. So this is a very dangerous thing, right? So imagine your plane is taken off already and you didn't detect any fault, but the fault came when you're on the flight. So this one may cause a danger or personal hazards. So over here, we can see the kind of ESD effects on the different devices here. So because of that, we need to actually ensure that we have a static free controlled environment. So what is this environment about? Okay, first of all, these are the precautions to be taken, right? First, you need to put signs on it, okay, in the place that you're working. If there are a lot of ESD or electrostatic sensitive devices, so you need to put signs as a warning. Then you must ensure that any insulating material such as nylon, rubber, fiberglass, styrofoams, or any plastic products, okay, all these will be kept out of the area. Then anyone who is working there must wear ESD coat and ESD shoes. Okay, these are the attire you need to wear to make sure that you do not have any discharge on the component. Right now, if you're wearing this shoe with the anti-static heel, you must put the cable of the ground cable into the socks. Why? So that this cable here will be in contact with your skin. Okay, right? So then the floor is to be covered with conductive paints or coating or mats to provide a surface that's free of static discharge. Okay. And then you must place a sign to warn people that these static control precautions are required in the area so that they will know. And this is the typical workplace of static safe workstations, right? So you need to wear a wrist strap, and you see that this table mat here is connected to here and goes to the ground. Okay, so this is the wrist strap. So you must be secure around the wrist all the time while you're seated and working on the workstation to make sure that there's good connection, electrical connection to the skin to dissipate any electrical charge to the ground. Before, okay, the keyword is here, before you touch those devices. So you must make sure this happens before you actually work on the device. Now, it is not practical, right, to raise the humidity to a high level, right? Because if the humidity is high, there's less chances for electrostatic to take place. So it is, but to raise it so high is not comfortable for human being. So what we do, we actually use the air ionizer, okay, ESD air ionizer. So these are the various types here. We have a benchtop, okay, we have a gun, okay, this gun here is more directional on a certain area, or you have an overhead ionizer, right? So all the ESD sensitive devices should be transported in a closed conductive container, such as this one. And this container must be stored on the ground rack at the lowest rack and when moved to the workstation. It must make contact with the it must be a grounded table mat. Okay, so any accumulated charge on human body should first be discharged by wearing the ground static. Okay, this is what I've said earlier on. And then all the devices, electrostatic, you should use the electrostatic shield conductive bags, right? And then this warning over here. Okay, so now there are also instruments to actually test the devices, the environment also. You can test the environment, such as this grounding test station to test your shoes, to test your wrist strap, right? This is the test station you must have to make sure that your devices are working before you enter to the working environment.